We will now highlight some of the distance protection features that are available in more advanced distance relays, such as the GE Multilin D60. These relays will have both ground and phase distance protection elements available. The ground distance elements will detect faults between a phase and ground, while the phase elements will detect faults between phases. For both of these types of elements, there are 4 zones of protection available. Every zone of protection can be programmed to be protecting in the forward or the reverse direction of the transmission line. These zones can also be programmed to have a Moe or quadrilateral shaped protection characteristic. The operating characteristics of each zone can also be set individually. A distance protection relay is used to detect and clear faults that occur on a transmission line. It accomplishes this type of protection for both the phase and ground distance elements by measuring the current and voltage, and using this information, calculates the impedance of the line. If the measured impedance is less than the known impedance of the line, this indicates the line is now shorter than expected, indicating it is faulted. However, due to the inherent inaccuracies of CTs and VTs, the impedance calculations made by the distance relays cannot be guaranteed to be extremely accurate. For example, let's assume the actual impedance of our transmission line is 20 ohms. A fault occurs just past this transmission line on the next adjacent circuit. The actual impedance from the measurement point of the relay to this fault is 20.5 ohms. Due to the inaccuracies in the CTs and VTs, along with some transient effects, the relay may measure the impedance to the fault to be less than it actually is, and see the fault as being on the transmission line it is protecting. This would cause the relay to trip the circuit breaker and shut down this transmission line when it did not need to. Because of these inaccuracies, distance zones of protection are not set to stop right at the boundary of a transmission line. Distance relays use multiple zones of protection, with some of them set short to only protect part of a transmission line, and others set longer to protect the entire length of a transmission line, plus some of the next adjacent line. The zones of protection that are set to cover only part of a transmission line are said to be underreaching. The zones of protection that are set to cover more than just that relay's transmission line are said to be overreaching. Zones of protection can also be programmed to protect in either the forward direction or reverse direction. Zones that are set to protect in the forward direction are said to be looking into the line, while zones that are set to protect in the reverse direction are said to be looking out of the line. The strategy used to protect a line is commonly referred to as a scheme. All protection schemes used in distance relaying fit into one of 2 categories: pilot-aided and non-pilot-aided schemes. The main difference between the 2 types of schemes is that the distance relays used in pilot-aided schemes communicate with each other to determine whether the fault is located on the transmission line or not. The relays used in non